Hello, this video I explain question 2, 3, and 4. They're all related simple rate law questions. Okay, so rate law, with first and first, again, as always, we need to review the core information, what rate law is about. Okay, so if I have a generic equation such as over here, just I have A as my reactant, and then I just make products, right? Okay, so maybe I have a coefficient right over here. Okay, so then when I write out the rate law, right, the generic expression will be rate of this reaction. Actually, more specifically, should be initial rate of this reaction, y equals to rate the concentration, rate constant, multiply the concentration of the reactant raised to a certain power. Okay, so now let's explain the terms in this expression. K is the rate constant, right? A, of course, is my reactant. Bracket means concentration. And raised to a certain power, this is the reaction order. Okay, so that's basic idea, right? Okay, so that's that. Okay, so now of course further, right, we first and first know what it is. Now have to know some more detailed info, such as rate constant, it should be a positive value, and then for different reaction orders has its own unique units, and that's something we are responsible for. Of course, throughout these three questions, one of them is gonna work on that, right? Okay, and then the certain power, that power n is representing reaction order with respect of the reactant itself. That information can be only determined through experiments. Okay, so then therefore, with that information, let's look at this particular question, question number 2. Okay, so I have a reaction. Okay, and then it's telling you or telling us with respect of reactant A, the order is zero order. Okay, so and then with reactant B, the order is first order, and it's asking us to write out the rate law. Okay, so therefore the rate for this reaction equals to K is the rate constant, concentration of A raised to which power is going to be zero order, because again, that information we can only get it through our experiments. Okay, we don't look at the coefficients. We have to either we have experimental data, then we can, based on the data, solve it, or the question already give it to us. Okay, so right over here, telling us it's zero order, and multiply. Now I have a second reactant, and second reactant is B, and raised to the power of 1. Okay, so that's the expression. Of course, we can further simplify according to math. Any number is power 0, that will be 1. So therefore, this rate of this reaction actually just relies on what? Depending on the concentration of B. Okay, so then this will equal to K rate constant times the concentration of B. Okay, so that's how you work on that. Right, very easy question, but it does require we have that understanding. Okay, so similar, we're still using this information. Now we can work on question number 3. Okay, so it's saying a reaction was found to be second order in carbon monoxide. Okay, so therefore we can already, based on that sentence, we can already write out, okay, the rate law based on that information equals to K multiply concentration of carbon monoxide raised to the second power. The reason for that is telling us it's second order. Okay, so now the question is saying, okay, so now the rate of this reaction is going to be what if the concentration of carbon monoxide is doubled? Okay, if it's doubled, everything else kept the same, and what's going to be this new rate? I'm going to change the color. Okay, so the rate now, what's it going to be? Let's see how it's changing. Okay, so I was just saying, as the question said, K doesn't change, but what does change? Right, the concentration of the carbon monoxide is doubled. Okay, so that's why I added 2 times, right? It's doubled. And then still second order, that doesn't change. Now that's right, solve it. So the rate will equals to K. Of course, when I have the second order, that I need to apply to my number and to my concentration. So this turn into multiply by 4, multiply concentration of carbon monoxide squared. I just want to reorganize this real quick so then it's easier for us to see. You may already notice what's going on. So I'm going to put, right, do this. Okay, so then you recognize, okay, this really, right, just equals to rate equals to 4 times this piece. Look, that's that, right? equals to 4 times of the original rate of direction. So then therefore the rate of reaction did what? Increase by a factor of 4. Okay, so this still again based on our understanding about rate law, how concentration changes affecting, right, based on direction order, of course, then it's how it's affecting the rate of direction. Okay, so now let's look at the next question. It's still about rate law. And then what's this about? It's telling us the rate law itself is asking us the unit for K. Okay, so what the unit is. Okay, so if it's about unit, of course, we don't need the detailed numbers, and then we can, right? But we still can, since it's equal relationship, we can still work on it, rely on this equal relationship and work with the units. Okay, so then therefore, rate of a reaction, the unit will be molar per second. And we're looking for K, so leave as is. And the units for concentration is molar. Concentration is also molar, and they're both first order, so just as is. Now we're going to isolate K, everything else put on the other side. Okay, now we notice that can cancel out. So therefore, after we reorganize that is the answer, then you go, oh, the answer is not, but we understand, right? Molar is mole per liter. Of course, we can do that, and of course you work it out, then this will be the look of the choice from this question. Okay, so then the choice should be B. Okay, so these 3 questions are easy type of question based off rate law, but it does require us have the understanding. Once we understand, very easy, and hopefully this is helpful. Thank you.